All right, hopefully you're hanging tough with this last video. This will catch us all up. This is actually going ahead a little bit because we haven't gotten into the application questions yet, but here we go. We'll give it our best shot. So in example number 7, we have a parallelogram ABCD. So as soon as you have an object and it's not drawn out, please draw it out. So parallelogram is that tilted rectangle, okay? And once you start to label the parallelogram, continue to go all the way around. Do not go through or across. So there's my parallelogram. AB is 16, so this side is 16. BC is 23, that side's 23. The measure of angle C is 40, so that angle is 40. Find the length of diagonal AC. So I'm looking for this diagonal, okay? Well, what happens with a parallelogram is that these two triangles, triangle 1 and triangle 2, they're congruent. And what I'm going to do is I'm going to make my parallelogram question become a triangle question. So I'm going to separate out one of the triangles. This is 16 and this is 23. Now, I know that the bigger angle here is 40, but this diagonal does not bisect the angle. So I don't know what the measure of this is. It's not 20 and 20. So what I do is I use the fact that this angle here is 40 to determine what this angle is, because we know consecutive angles in a parallelogram are supplementary. So if this big angle here is 40, then I know this is 140. And I'm looking for the diagonal. So I have my triangle marked. Anything in here to lead me to believe it's a right triangle? No. Am I given side angle side looking for a third side? Yes. So I'm going to use the law of cosines. A squared is equal to b squared plus c squared minus 2bc cosine A. The angle I'm going to use is 140, so that's going to go right there. And the side opposite the 140 is my x, which is what I'm looking for. That has to go in for A. So x squared is equal to 16 squared plus 23 squared minus 2 times 16 times 23 times the cosine of 140 degrees. So again, doing the problem in pieces. So x squared equals, and I take the calculator out. I have 16 squared plus 23 squared. That's 785. Bring the minus down. That's the minus in the problem in the formula. And now I'm going to multiply 2 times 16 times 23 times cosine 140. And that turns out to be a negative number, minus 563.8087. A negative is a positive, so now I have x squared is equal to, and now I'm going to have 785 plus 563.8087, and I'm going to have 1348.8087. So x is going to equal, now I want to take the square root of that number, so second square root, second answer, and I want that to the nearest tenth. So 36.7 is the size of the diagonal. And that makes sense, because 140 is definitely going to be the largest angle, so this should be the largest side, and it's the largest side by a lot. All right, so that's example 7. And then finally, we get down to example 8. This is one that every once in a while they'll ask on the Regents. It's a good one. It's pretty easy. You just got to set it up. So two forces act on an object. So if you ever read this line in a problem, stop reading the question and draw the diagram. So we're going to make this the object, and I have a force acting on it and another force acting on it. Okay? That's all it is. And what's going to happen is, if I have a force pulling it this way and I have another force pulling it this way, where the object is going to go is going to be someplace between these forces. That's called the resultant force. Okay? So this is really kind of force 1 up here. This is force 2. This here is the resultant force. Okay? It says that one force has a magnitude of 38 pounds. The magnitude of the force is going to be the length of the side, the length of that side. The magnitude of the second force is 45 pounds. So this side becomes 45. Find the magnitude of the resultant force. That's this force in here. We're looking for the magnitude of that resultant force. If the angle between the two forces, this angle in here, is 38. All right? So the way we do a force question is we finish the diagram, and we finish the diagram making it a parallelogram. And since this is a parallelogram, I can break it up into the triangles that you see. So I'm going to take the top triangle. I know that this is 38. I know the resultant force is what I'm looking for. Remember, I don't know what the smaller angles are, and that's what I have. I have the smaller angle here. I don't know what that smaller angle is, so I can't mark anything in here. This force is 45 pounds, and I know in a parallelogram, the opposite side's also 45 pounds. All right? And know that the relationship between this angle and this angle is that they're supplementary. So if this angle is 38, then this angle is 142, and that's that angle right there. Okay? So I'm looking for x. So it's not a right triangle. Am I given side angle side looking for the third side? Absolutely. So this is going to be a law of cosines question. So a squared is equal to b squared plus c squared minus 2bc cosine a. The angle I'm going to use is 142. The side opposite that angle is x. So I'm going to have x squared equals, then I have 38 squared plus 45 squared minus 2 times 38 times 45 times the cosine of 142. Sorry, it's getting kind of blocked out there. All right, so now I'm going to do this in pieces, remember. All right, so I have x squared equals, now I take the calculator out. I have 38 squared plus 45 squared. I get 3,469. Minus, that's the minus in the problem. Then I get 2 times 38 times 45 times cosine 142. I get another negative, and this is 2,694.996, rounding it to 4 decimal places, 8. A minus becomes a plus, so I have x squared is equal to, I need to add these two, 3,469 plus 2,694.9968, and I get 6,163.9968. So x is going to equal, I take the square root of that answer to the nearest tenth, 78.5. So that's going to be the magnitude of the resultant force, and if it's in terms of pounds, it'll be 78.5 pounds. Okay, that concludes your review, your catch-up, and actually moving on to some of the new stuff. So I hope you guys take the time tonight and look this over, and I'll see you tomorrow.